Welcome dear students. In today's class, today we will discuss about graphical representation of motion and equation of motion by graphical method, which are the topic of your NCERT textbook class 9 science. Learning outcomes. By the end of this video lecture, students will be able to plotting of graph between different quantities, equation of motion v is equal to u plus at, s is equal to ut plus half at square, and v square minus u square is equal to 2as. Derivation of above mentioned equations by graphical method, able to calculate numerical related to equations, textbook numerical problems related to the topic. Graphical representation of motion. As you have studied in mathematics, a straight line graph helps in solving a linear equation having two variables. For describe the motion of an object, we can use line graphs. In this case, line graphs show dependence of one physical quantity such as distance or velocity or another quantity such as time. First graph, distance time graph for uniform motion. Uniform motion is known as uniform speed motion for a straight line. In this situation, uniform speed is equal to uniform velocity also. When an object travels equal distance in equal intervals of time, known as uniform motion. This shows the distance traveled by the object is directly proportional to time taken in this graph. The portion of this graph shows that the distance is increasing at a uniform rate. So you can also use the term uniform velocity in place of uniform speed. If you take the magnitude of displacement equal to the distance traveled by the object for a straight line motion, we can use the distance time graph to determine the speed of an object. Next, non-uniform motion. We know when an object travels unequal distance traveled in equal interval of time known as non-uniform motion. Another name of this motion is accelerated motion. For non-uniform motion, the distance time graph is non-linear. The nature of the graph is non-linear for the non-uniform motion. Next, when an object at rest, for this situation, no any moment by the object, so distance time graph is a straight line on the time axis. This graph represents the object at rest. Next, velocity time graph for uniform motion. In this graph, we represent the variation in velocity with time for an object moving in a straight line. It means with uniform motion. Object move with uniform motion. In this situation, object also having uniform velocity. Uniform means constant. So graph is a straight line parallel to the x-axis. We know the displacement of an object is equal to the product of velocity and time, we can easily calculate this quantity by velocity time graph with the help of this relation, area enclosed by velocity time graph. This area enclosed by the velocity time graph represent displacement of an object. We can also study about uniformly accelerated motion by plotting its velocity time graph. Uniform acceleration. Uniform acceleration means equal change in velocity in equal intervals of time. Here, velocity time graph. This is also a straight line inclined to time axis. It means the rate of change of velocity is equal in equal interval of time. With the help of this graph, we can also determine the distance moved by the object. Distance means magnitude of the displacement. And next, non-uniform accelerated motion. Non-uniform accelerated motion means unequal change in velocity in equal interval of time, so known as non-uniformly accelerated motion. For this motion, graph is non-linear. Velocity time graph is non-linear graph. The nature of the graph is non-linear. Second, with the help of velocity time graph, we can calculate the acceleration also. Equations of motion by graphical method. First equation of motion is v is equal to u plus at. Second, s is equal to ut plus half at square. And third, v square minus u square is equal to 2as, where u is the initial velocity of the object which moves with uniform acceleration small a for time small t. V is the final velocity and s is the distance travelled by object in time t, and a is uniform acceleration. Equation for velocity time relation, this is known as first equation of motion. We derive with the help of velocity time graph. This graph for uniformly acceleration. So here this is reference point O, point A and B. Initial velocity is small u. In this situation, initial velocity is not equal to 0. You can see the initial velocity of object is small u at point A, and then it increases to v. At point B in the time small t. The velocity changes at a uniform rate small a. In this figure, the perpendicular lines BC and BE are drawn from point B on the time and the velocity axis respectively, so that the initial velocity is represented by OA, the final velocity represented by BC, and the time interval small t represented by OC. Next, we draw a parallel line with OC from A to D. So, BD is equal to BC minus CD represents the change in velocity in the time interval small t. From the graph, we observe that BC is equal to BD plus DC. This is equal to BD plus OA because DC is equal to OA. Substituting BC is equal to small v and OA is equal to small u. We get V is equal to BD plus small u or BD is equal to V minus u equation first. From the velocity time graph, the acceleration of the object acceleration is equal to change in velocity upon time taken. This is equal to BD upon AD. AD is equal to OC. Substituting OC is equal to small t, we get small a is equal to BD upon small t. Using equation first, and equation second, A is equal to V minus U upon T. This implies AT is equal to V minus U. So we get V is equal to U plus AT. And this is the first equation of motion. With the help of velocity time graph. Next, second equation for position time graph. This is known as second equation of motion. Let us consider the object has traveled a distance small s in time small t under uniform oscillation small a. In graph, distance traveled by the object is obtained by the area enclosed under the velocity time graph AB. We represent the A, B, O, C and D. The distance traveled by the object by the object is given by S is equal to area under OABC. This shape is trapezium, which is a trapezium is equal to area of the rectangle. We can divide the area of trapezium in two parts. First is rectangle OADC. So area of the rectangle OADC and blue shaded area of the triangle. Area of the triangle ABD. We know the area of the rectangle is width into length. So OA into OC. OA is the width for rectangle and OC is the length plus area of the triangle half into base into height. So in this triangle base is AD and height BD. Equation third. Substituting OA is equal to small u, OC is equal to AD is equal to small t because we know the OC and AD both are similar and BD is equal to AT from equation first. So S is equal to U into T plus half into small t into AT. S is equal to UT plus half AT square. Second equation of motion. Next, equation for position velocity relation. This is known as third equation of motion. Same from the velocity time graph, the distance traveled by the object in time t is small s, moving under uniform oscillation small a, is given by the area enclosed within the trapezium O A B C under this graph. So S is equal to area of the trapezium O A B C. We know the area of the trapezium is half into sum of two parallel sides. In this trapezium, parallel sides is OA and BC. So OA plus BC into distance between two parallel sides is OC. Equation number 4. Substituting OA is equal to small u, BC is equal to small v, and OC is equal to small t. S is equal to half of v plus u. We can interchange both terms. First I put value of BC and second OA. We can interchange this because both are in addition into small t. Equation number 5. From the first equation of motion, we know AT is equal to V minus U. This implies, we find the value of T. Small t is equal to V minus U upon small a. Equation number 6. Using equation 5th and 6th. So S is equal to half V plus U, and put the value of T from equation 6 to equation 5th. V minus U upon A. Here using a mathematic algebraic identity, A plus B into A minus B. So we know A plus B into A minus B is equal to A square minus B square. But here we have V and U. So V square minus U square upon A. So AS is equal to V square minus U square. This is third equation of motion. Now we solve a numerical problem with the help of equation of motion. So here a car accelerates uniformly from 18 km per hour to 36 km per hour in 5 seconds. Calculate the acceleration and the distance covered by the car in the time. Solution. First, we are given that initially car accelerated from 18 km per hour. It means initial velocity u is equal to 18 km hour. We convert in meter per second. So 18 into 1000 upon 3600 meter second. So we calculate 5 meter per second. And finally V is equal to 36 kilometer per hour. Using above relation, same, convert in meter per second. So 36 convert 10 meter per second. And time and t is equal to 5 seconds. First part, acceleration. We know the acceleration a is equal to v minus u upon t. Putting the value 10 meter per second minus 5 meter per second upon 5 seconds is equal to, solve it, 5 meter per second upon 5 seconds. This implies A is equal to 1 meter per second square. Answer of first part. For second, from distance covered by the car. So from equation of motion, which equation? Second. So we know S is equal to ut plus half at square. Using value of u, t and a. 5 meter per second into 5 seconds plus half into 1 meter per second square into 5 seconds into 5 seconds. 5 5 ja 25 meter plus 25 by 2 meter. Take an LCM. 25 2 ja 50 meter plus 25 meter is equal to 75 by 2 meter. So S is equal to 37.5 meter. This is the answer of second part. I hope you understand all topics. Thank you.